For the last 2 weeks, we've been practicing a technique called use substitution. It's a very good technique and it allows us to solve integrals of the form natural log of x over x. Okay, however, it cannot solve integrals as simple as the natural log of x. So how can we solve something like this? In this week, we're going to introduce another technique, which is very likely to be the most versatile technique in the standard education of calculus. This technique is called integration by parts. It is very useful for solving integrals of the form fx times g prime of x, where the two functions f and g can be irrelevant. Okay, so what is the formula for this and where does the formula come from? The formula comes from a very simple observation. So recall from calculus 1 that the derivative of a product of functions, so the derivative of fg is equal to f prime g plus fg prime. Now that we are familiar with the language of integration, we can try to integrate both parts. Then what we're going to get is fg, which is the antiderivative of fg prime, is equal to the integral of f prime g plus the integral of fg prime. Both integrals are with respect to the variable x. Okay, so from this, we can deduce that the integral of fg prime is equal to fg minus the integral of f prime g. And this is the standard formula for integration by parts. So in your textbook, it also introduces another notation, which is very concise. So if we write u for the function f, so this u is different from the u we used for u sub. And we write v for the function g of x, then du is equal to f prime dx, and dv is equal to g prime dx. All right, then we can rewrite this formula as the integral of u dv is equal to uv minus the integral of v du. So in this way, it has a very nice sense of symmetry. And of course, it's much more concise than this formula. However, it is a little bit difficult to understand what exactly is going on. So this one is still what I prefer. All right, so finally, I want to give you a few remarks. So here I just rewrite the formula. Okay, let's look at this formula and think about this. So before, we were trying to evaluate the left-hand side. And this formula looks like it transfers this simple expression to be a much more complicated expression. So what is the benefit for doing so? This is our first remark. When to use this formula? So we only want to use this formula if the right-hand side is easier to solve than the left-hand side. And more precisely, we want to use it when the integral of f prime g, here I'm abbreviating the notation, is easier to solve than the original integral f g prime. Of course, we'll see examples in the next video. A second remark, this is still not a general formula. In other words, it cannot solve everything. And after this class, you will realize that integration is indeed very difficult, and nothing can solve every integral. So cannot solve everything. Okay, a final remark. If we compare integration by parts to U sub, they are not mutually exclusive. They are not mutually exclusive. So sometimes one works better, sometimes the other works better. But in many cases, you can use both. And in some really difficult cases, you have to use both. So for example, you will use U sub to first simplify the original expression, and then you will get an answer by using integration by parts. Okay, so these are all I want to say in this introductory video. I'm going to let you to read the textbook, and we're going to do 2 examples in the next video.